So, very warm welcome to everyone. Also, Happy New Year to the members of the editorial team that we haven't spoken to yet. And welcome to everyone from the Netzwerk Macroeconomic, which we also invited today, and everyone else. To explain to you, this is the global lecture, the Global Exploring Economics lecture with Professor Steve Keen, which is a reward for our editorial team that are currently going through an editorial program with us for 4 months. And we are now in January, so the program will go until February. If you're not part of this program, you can also participate again, probably from April. So you can already remember that. But more about that you can find on the website, which we will post a link also in the chat. Yeah, so what is the plan today? You can already see, and you could already hear Professor Keen. He will present for us today. Steve Keen is an Australian economist, for those who don't know him. He lectured at Kingston University in London for quite some time, was the head of department there. He's the author of several books you can already see over there, and for example, Debunking Economics was really, probably one of the manifestos for the curriculum change movement and the heterodox movement. So he's an important heterodox economist as well. And I will hand over the microphone to you just now. Just roughly, we thought about 40 minutes, and then you have time for questions. You can just write down the questions, everyone, and then later you can write in the chat and raise your hand. You can just write HAT, so it's H-A-T, and then we will pick you and unmute you, and then you can ask your question to Professor Keen. So over to you.
Okay, thanks very much. Okay, well, I'm glad to be contributing here. I have a lot of sympathies with the rethinking movement because I began a similar campaign myself back in Sydney in 1972. So I have a long history of trying to reform economics, and I know how difficult it is and how important it is to have a movement like yours. So congratulations on that. What I'll be talking about today is, I see a way of developing a new approach to economics which has what neoclassicals think they have, which is a sound foundation. And my work in modeling economic dynamics began with Hyman Minsky's work on financial instability. And there's many ways you can approach Minsky. The way that I approach him pretty much starts from the paragraph you can see on screen right now. The natural starting plate for analyzing the relationship between debt and income. Now, according to mainstream economics, there is no relationship. And even according to some parts of heterodox economics, they can't actually see what the relationship is. But I thought that was a perfect starting point for what I thought was the only, or the most complete vision of capitalism I'd ever seen came out of Minsky's work. And he then said that, again, the idea about what causes instability in capitalism, rather than focusing upon a tendency towards stagnation, which is what you'll find in some critics of capitalism and even the mainstream these days with their secular stagnation nonsense. Minsky was saying the fundamental instability is upwards, the tendency to turn doing well into a boom, a speculative investment boom, is the basic instability of a capitalist economy. So that's what I took as my preferred starting point for Minsky. And now because Minsky was unknown before the financial crisis, or known only to heterodox economists, now everybody knows Minsky, but very few understand him. If you look at what the neoclassicals have to say, I read their papers and I simply can't see Minsky in them most of the time. But if you look at the models which have been done by genuine post-Keynesian to understand what Minsky was trying to do, most of them are still seen as being ad hoc. In other words, making arbitrary assumptions to get the results they get. And the mainstream, on the other hand, thinks that it's got good foundation. They talk about having solid micro foundations, deep parameters, blah, 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 all that sort of thing. Now, this is from a dictionary of political economy by a guy called Barclay Rosso, who's one of the leading promulgators of a nonlinear approach to economics. And there's the claim about the models being ad hoc, derived from Minsky from Keynes to some extent, and he mentioned the financial instability hypothesis as an example of a model based on ad hoc foundations. Now, my first model of Minsky I did back in 1992, published in 1995, and I've since realised that I can derive that model directly from macroeconomic definitions. That's what I want to take you through today. If you define the employment rate as the number of people with a job divided by population, you cannot disagree with the definition, okay? If I had something else in there, if I had something other than number of people with a job, you could disagree with that. But once you've defined it properly, that is an incontrovertible foundation. Equally, the wages share of GDP is just the wage bill divided by GDP. And the private debt ratio is the level of private debt divided by GDP. So those are simple definitions. That's why I'm using the triple equal sign rather than the standard two part, because this is defined as being the following thing. And then the output to employment ratio, so the level of output divided by the number of workers, and the capital output ratio, the level of capital divided by output. Those are the 5 terms I'm going to be working from, which are all definitions. Now, I don't go through doing it here. I'm happy to show if anybody wants to see why. I can talk about that in the discussion period. But if you differentiate those with respect to time, you get a very simple expansion. And what you've now got is you get a way of rephrasing those definitions in a dynamic context. So if you differentiate the employment rate, you get a differential equation that says that the percentage rate of change of the employment rate is the growth rate minus the sum of change in the labour to output ratio or labour productivity and change in population. And that's simply a definition still. It's not a model as yet. The same thing for the wages share of GDP. This is quite obvious. If you have the wages share of GDP as wages divided by GDP, the rate of change of the wages share is the rate of change of wages minus the rate of change of GDP. So the wage, that's basically, you can phrase that in a linguistic way, the wages share of output will rise if wages grow faster than GDP. And finally, the debt ratio will rise if debt grows faster than GDP. Now, those are all in terms of percentage rates of change. Now that you can't deny those definitions. They're simply definitions. So in that sense, that's why I see it as a good foundation. Now, I'm going to use very simple linear relationships to turn this into a model. So I'm going to have a linear Phillips curve. For those who don't do economics, a Phillips curve is the term we economists apply to a relationship between the rate of employment and the rate of change of money wages. So this is saying the rate of change of money wages is a function of the employment rate, and you have a slope of the line multiplied by the employment rate minus a point at which there's no change in wages. It's a very simple linear equation. And similarly for investment, I have investment as a share of GDP is a function of the rate of profit, and there's a slope of the profit function multiplied by the actual rate of profit minus the level at which capitalists simply invest what they earn. They don't borrow and they don't repay debt. Now, they might themselves be seen as ad hoc, but one of the things we learned from mathematics is that a linear equation is the very first set of terms in a polynomial expansion of a more general function. So it's only ad hoc in the sense that it doesn't have the nonlinear terms, but the linear terms dominate when you're near the equilibrium of a system. So if you're trying to work out whether a model is stable or not, you simply use the linear terms, because close to zero, the linear terms are bigger than the x squared terms and x cubed terms, because 0.1 is bigger than 0.01, bigger than 0.0001. So what the linear terms do tells you what will happen near the equilibrium, whether it's stable or not. And this is giving you the fundamental structure of the economy. What happens coming out of this comes out of the structure of the economy. And when you expand these equations out, I'm doing some substitutions here, you get the rate of change of the employment rate is the employment rate multiplied by the growth rate minus the sum of labour productivity change and population change. The wages share of GDP will rise if wage demands exceed changes in labour productivity, and the debt ratio will rise if investment minus profit share minus the debt rate times the growth rate is greater than zero. That's a fairly more complicated term. Now, when I spell the model out in full, and you can just simply take the algebra I've shown you so far and produce these equations. So the terms in red are the system states, the employment rate, the wages share of GDP, and the debt ratio. And what I'm doing, I'm highlighting where they're multiplied, where the terms are multiplied against each other. So you have the employment rate here multiplied by the negative of the wages share and the negative of the debt ratio. That gives you two, what are often called negative feedbacks in system dynamics. I prefer to call them dampening feedbacks because that's a more accurate statement of what's going on. a negative feedback dampens a change. So if you're away from equilibrium, a negative feedback will push you back towards it. Now what's going on here is an amplifying feedback, which is called positive feedback in the language. I think amplifying is more obvious. So this will push you away from equilibrium. And over here I've got the debt ratio, minus the debt ratio times minus the wages share and minus the debt ratio again. So those are two more amplifying feedbacks. So that is a model which has very simple behavioral assumptions, in fact linear behavioral assumptions, but you get nonlinearity out of it because in the model itself one system state is multiplied by another. So you get, when you solve for the equilibrium of the system, you get two meaningful ones, one with a finite level of employment rate, wages share of GDP and debt ratio, and the other with infinite debt and zero employment and zero wages. Now you can guess which one you'd prefer to converge to. And when I model this, and I model this in my software package Minsky now, what you get is a convergence to equilibrium over time if you start with a relatively low level of the desire of capitalists to invest. So I'm trying to bring that model up. I've just actually clicked on it to start it. I'm trying to see where it actually got to. Here we go. Okay, so that's the model. Can you see it on screen? Good. Yes. Okay, good. I'll just make it a bit larger. So this is what is happening here. This is the profit share being defined. So the profit share is 1 minus the wages share minus interest on the debt share, and divide by the capital output ratio, get the rate of profit. That's what's going on here. And the employment rate, this is the same equation I showed you a moment ago, but now done as a flow chart. Same for the wages share and same for the debt ratio. Now I'm going to start this with a fairly low level of it looks steep, but it's just a low slope for the profit function. So this tells you how reactive capitalists are to profit being higher than they need to. But it's a slope of the function. Yeah? How much does investment increase given the level of profit? Now, if I simulate this model, I hit the run button up here to show the simulation. You'll see this is converging to equilibrium over time. So what I'm plotting here is the employment rate, which is cycling but heading down towards a stable level. The growth rate over here, I'll let it run a bit further. The wages change, there you can see wages change, the debt ratio, and these are plotting one variable against another. So on the horizontal axis here, I've got the wages share of GDP. On the vertical, the debt ratio. Here I've got the profit share and the debt ratio. And you can see the model is converging fairly slowly towards an equilibrium point. So that's, you know, what neoclassical think happens all the time with equilibrium. Now, what I'm going to do now is increase the slope of the profit function. So I've changed the slope from 5 to 10. And I want you to look at the difference, to keep that picture in your mind as to what happens with a low level of desire to invest. This is what happens with a high level. Now you can see a few things. For a start, the debt ratio is higher. Notice the slope, this tilt in the function here with the wages share versus debt. This is going straight up. This is the profit share versus debt. So it's cycling straight up, but the wages share is tilting over. And notice the cycles are dampening more rapidly than the previous case. So it looks like you're heading towards equilibrium faster. But if I run the simulation a bit longer, you weren't heading towards equilibrium. You were heading towards a level of breakdown, cycles leading ultimately to the breakdown. If I keep this going on for long enough, you'll have the debt ratio that gets more and more unstable, debt over the wages change, and ultimately the system breaks down with zero employment, zero wages share, and infinite debt. So that's this model, very, very simple model, giving these two very different outcomes. And what I want to just highlight now is some aspects of the dynamics here. Notice there's diminishing and then rising cycles. Now that's what happened back in the last 25 years. We had a period of falling cycles in employment and the growth rate, which neoclassical called the Great Moderation, and took the credit for causing it. Then we had what they called the Great Recession, which they blamed on an exogenous shock. Now I've generated both those phenomena, the stylized version of them, but both those phenomena out of one model. So it's not their separate processes. There's something you can only understand with a complex system perspective. Notice the rising level of debt to GDP, which we've seen empirically, rising level of private debt to GDP, rising inequality because as the debt level rises, it's actually workers who get less money, not capitalists. They get the same amount, fluctuating, but the same basic trend. So the workers pay for the high level of debt, and that is, in fact, what we've seen in the real world. Now, that's the very simple model that doesn't include price dynamics. Again, using the same basic idea, work from definitions, I can produce a model that has inflation dynamics in it as well. So it's fundamentally the same model with two major changes. Prices are now part of the system, and I explained how I drive prices in the paper I sent to you a while ago. And then a nonlinear behaviour in terms of wages, workers' reaction to the employment rate, and capitalist reaction to the level of profit. Now, if I, pardon me, this is now laid up as a flow chart, by the way. So to take you through the flow chart, this is saying gross investment minus depreciation equals net investment, which when you integrate it gives you the level of real capital. If you multiply that by the price level, you get nominal capital. If you divide it by the capital output ratio, you get real output. Real output divided by labour productivity gives you the employment rate, divided by population, so it gives you the level of employment, divided by population gives you the employment rate. Feed that into a wage change function, you get the level of wages. Multiply that by the number of workers, you get nominal wages. Subtract nominal wages and interest payments from nominal output, you get nominal profit. Divide that by the nominal value of capital, you get the rate of profit. Feed that into an investment function, you get gross investment. If gross investment is greater than gross profits, you have a change in debt. And if you have a change in debt, you've got to pay interest on that. And you pay interest, which is the nominal rate of interest times the level of debt gives you the nominal level of interest, which is subtracted over here. Now, the rest of this is just definitions. Now, if I simulate this model, it's got more complex behavior than the one I showed you with this simple linear behavior, much more complicated dynamics. But the same basic principle applies. What we've now got is a process of debt deflation, like Irving Fisher used to explain the Great Depression. And notice how everything seems to settle down and then it collapsed. Wages share is tending down, cycles, and then seems to be stable and then collapses. My favorite is the profit share here, which looks like it's gone through a period of instability and finally it stabilizes. And then just after it stabilizes, the economy collapses. I'll just continue that simulation a bit longer. So the last one to realize capitalism is collapsing at the capitalists. Now that's an incredibly simple model in terms of how few steps were used to derive it, but I think you can see the impact of its behavior overall. It's rather more like the real world than the models we see in neoclassical textbooks. Now, part of this, part of Minsky's hypothesis was that there's an essential role for banks in creating credit as part of this cycle. And this is an area which post-Keynesian economics is still not up to speed on. We still haven't properly integrated the role of credit into aggregate demand. And if you look at, there's a recent fairly acrimonious blog exchange between Doug Henwood, who's a critic of MMT, and Randy Wray, who's of course a creator of MMT. And this is Randy Wray replying to one point that Doug Henwood made when Doug Henwood commented that in MMT it seems that they don't take the endogenous money idea seriously anymore. And what Randy Wray says here is that there's not much that really comes out of endogenous money apart from telling central banks that they should control interest rates rather than the money supply. But on the other hand, MMT has a dramatically different effect, but overall, implication of endogenous money are trivial. Now, I agree with MMT about the role of government money creation, but I think that they haven't properly understood the role of credit because it's not trivial, and I want to show why that's the case. And this has been a long-running debate that I've had in post-Keynesian economics with myself, Mark Lavoie, Brett Feiberger, Thomas Pally, and quite a few others. And I've finally got a resolution to this, showing the role of credit in aggregate demand. So what I'm doing here is breaking the economy into three sectors on a horizontal row on this table, showing expenditure by each sector. And the expenditure is shown as a negative in each row, and where the money is spent is a positive in each row. So each row necessarily sums to zero. And that is what I call a Moore table. Now, when you look at this table, and say you're looking just at three sectors and there's no borrowing of money and no lending of any form, then I have sector one spending A dollars per year on sector 2 and B dollars per year on sectors 3, and then receiving C and E dollars per year from sectors 2 and 3 on itself. So there's expenditure by sector 1. There's the income that generates. Necessarily they sum to 0. There's the income for sector 1, and of course that can income from different expenditure. Now, if you look at the diagonal, the negative of the sum of the diagonal is aggregate expenditure. And if I then say, well, what's the value of that? If I add up the flow of A plus B plus C out to F dollars per year, I can basically say it's the velocity of money times the amount of money in existence, which is pretty much Milton Friedman's world. Now, loanable funds, which is the neoclassical vision of how banks actually operate, which we know, thank God, I don't have to insist is false anymore because central banks have done that for me. But I've now included lending by one sector to another sector, which is the idea of loanable funds. The bank is just an intermediary. The lending is actually from a saver to a borrower. So there's the flow of credit from sector 2 to sector 1. I then have sector 1 spending that credit on sector 3. And then if you look at sum up the negative of the diagonal or sum up all the off-diagonal elements, you'll find you now get interest turning up as part of aggregate demand. But credit, which is in the table, has disappeared because it cancels out both along the diagonal and across the row. But when you're looking at expenditure or income, it cancels out. So if the neoclassicals were right that banks were just intermediaries, you could ignore banks in macroeconomics. Let's look at the real world. That's where they bring in a banking sector as well. So now looking at it in terms of assets and liabilities and equity of a bank. And what the bank does is lend money to sector 1, which sector 1 spends then on sector 3, and then sector 1 pays interest to the bank. So looking at that as stage by stage, there's the creation of credit, there's the expenditure of credit. Now, when I do the same trick of adding the diagonal, the negative of the diagonal, credit turns up as part of aggregate demand. It does not cancel out. So aggregate demand is the turnover of existing money plus gross financial transactions plus credit. And if you leave credit out of your macroeconomic model, you've left out a huge part of the actual dynamics of capitalism. And that's why this is so important. So you can't ignore banks or debt or money in macroeconomics. Credit is an essential part of aggregate demand. If you don't have banks in your model, and you don't have banks creating money, you're missing out on a huge part of what actually causes booms and busts in capitalism. Now, what I'm doing here is showing the same thing in a Minsky model. So this is my software Minsky again, which has been primarily designed to model financial transactions. So this is loanable funds. The consumer sector lends from its deposit account to the investment sector's deposit account. The investment sector repays the consumer sector. The investment sector pays interest, and the consumer sector pays a fee to the banking sector. That's the basic logic there. This is looking at it from the point of view of the consumer sector itself. This is what Minsky lets you do. So these are the various tables in the Minsky model I'm about to show you. And if I now bring up this model, this is now another model done in Minsky. And make it a bit larger. Maybe I'm actually going to drag some of this, just to make a bit more space. I'm going to drag some of the components of the model around to make a bit more room on my display here. So just give me a second to do that. So just make some of the components a bit bigger. Let's now go and zoom there. Okay, you can see over here I've got tau L, which is what I'm calling a time constant, telling you how fast banks lend money, and tau R, which is a time constant for repayment, how fast debtors repay. So can you see the numbers on your displays there, or are they too small? There's a 7 there and a 9 there. So what that means is I'm assuming it takes, roughly speaking, 7 years to double debt and 9 years to halve it. And then I've got loanable funds. This is a model of loanable funds. So I bring up the Godley table for this and show that on screen here. There's the lending by the consumer sector, the investment sector, repayment, interest, fee, et cetera, et cetera. So these are live models. They're not just tables in an Excel sort of sense. They're actually live parts of the model. Now, if I simulate this, you'll see there's an increasing level of debt to GDP, an increasing level of debt over time, but no change in the money stock. And if I now say, well, let's increase the rate of lending, watch the growth rate here. If I increase the rate of lending by saying it rather than 7 years, it takes 5 years, notice the growth rate drops when the level of debt increases. If I slow down repayments, so it takes longer to repay debt, there's another fall in the debt level, in the growth rate. The economy ultimately stabilizes back to about $200 billion per year or whatever. Huge increase in the debt ratio, bugger all in GDP. If I now go in the opposite direction and speed up repayment, the growth rate actually picks up a bit when debt's repaid. Slow down lending as well. Notice that now a plunge in the debt to GDP ratio. But overall, huge changes in the debt to GDP, private debt to GDP, nothing much in the economy. So if the loanable funds was accurate, you could ignore the banking sector. Now, what Minsky lets you do is rapidly, far more rapidly than any other program, modify, as well as developing models of financial flows, you can also modify them very rapidly. So here's the consumer sector's view of the economy, and that's the banking sector's. And show that, notice debt here, D for debt, is shown as an asset of the consumer sector because in loanable funds, it's a non-bank that does the lending. Now in Minsky, I can say, well, that's a fiction. So I'm going to delete the debt column and I'm going to delete the financial operations that don't actually occur between two non-banks, they occur between a bank and a non-bank. Then I can come up to the bank's view of the economy. And because I've deleted debt as an asset, it's still sitting there as a liability. So if I click on the plus key here, I can create room for an extra column. And then if I click on the down arrow here, that goes looking for liabilities that haven't yet been allocated as assets. D for debt turns up. If I click on that, just watch these two rows here, by the way. When I click on D, those operations are brought across and the Minsky makes sure those rows sum to 0. It's telling me I've got to do something about showing where the interest payments go. So I say interest going there. I'm going to delete the bank fee. Now I've made no other changes to the model. I'll go back to the same initial conditions that I started the simulation of loanable funds with and show you how different this world is to the loanable funds world. Now for a start, you can see debt and money supply rising in tandem. The growth rate is positive. GDP is rising, completely different world. If I now speed up lending and slow down repayment, the economy goes into a boom. If you go in the opposite direction, repayment more rapidly and lending more slowly, the economy goes into a slump and you actually have negative growth rates. I'll go back to the initial positions again. Now, that is the world we live in, okay? Changing amounts of credit, changing economic activity. You can see over here a very dramatic relationship between credit and GDP. Booming credit causes booming GDP, collapsing credit causes collapsing GDP. So that's the real world, and that's the one that Minsky was modeling. And in that world, you must think about the banking sector. You must have banks in your model, and that shows in a modeling sense or a simulation sense, the significance of endogenous money. So that's what I've taken you through, just doing it live there with the Minsky program. So with loanable funds, the economy, the bank sector is pretty much irrelevant. The economy can actually expand when debt falls and shrink when it grows. With what I call bank originated money and debt, GDP rises with rising credit and falls with falling credit. So this is just again to compare those two simulations. There's a couple of charts to show how credit and growth move in opposite directions in loanable funds. They move in the same direction in endogenous money. So it's a very, very major change in how you think about the role of banking and the role in macroeconomics. Now, looking at the empirical record, this says, well, you've got to worry about the level of private debt. And this is what actually led me to anticipate the financial crisis before it happened. I saw this, roughly speaking, exponential trend in private debt to GDP, so that simply can't go on indefinitely. When the trend breaks, there'll be negative credit, and that'll cause a recession. And notice here, the blue line is the annual change in private debt, which I define as credit. So debt is what you owe in dollars. Credit is the change in your debt in dollars per year. And credit reached a peak of about 15% of GDP. Before the financial crisis, it hit a trough of minus 5% afterwards. That's why the crisis is so severe. Now, if I look at the relationship between credit and unemployment, I get a ridiculously strong inverse relationship between the two. This is what the mainstream ignores. And that's they're ignoring a major factor, what actually causes the economy's ups and downs. Equally, when I've explained this in the paper I said along to accompany the talk, when you look at the level of asset prices, especially housing prices, you find a relationship between change in household credit and change in house prices. And again, that's massive, and it gives you warning that a financial crisis is about to occur before the crisis occurs. All this stuff is very, very powerful compared to what the mainstream does. Now, I've managed to build a database going back to about 190 years ago of level of private debt in America, which is the red line, and level of credit in America, which is the blue line. And when you look at it, you can see there's the Great Recession, as Americans call the crisis in 2008. There's the Great Depression. Now, I didn't even know about this one until I plotted this data. It's called the Panic of 1837. If you take a look at it, the period of negative credit there was deeper and longer than the Great Depression. So it was actually a bigger crisis for America than the Great Depression was, even though it had a lower level of debt, because the rate of decline of debt was so high that the negative credit was enormous. And you look back at the period before the Second World War, between 1834 and about 1937, so pretty much a century, there were 13 negative credit events in that period. Look at the post-war period, there's only been one. So it's a major way of distinguishing the change in the nature of the economy to look at the role of credit. So that's a very, very fast rate. I've actually gone faster than I intended. I think I've actually finished in what, about 35 minutes. I'll quickly just finish up by showing what the potential for Minsky, because I would really like you students to learn how to use software like Minsky and to start building dynamic models, monetary, non-equilibrium models of the economy, which is what Minsky is designed to support. This horrifying looking thing here is a model of the Portuguese economy. Okay, all this stuff down the bottom, all these sort of, I call them spider webs. These are basically defining various elements here. So you can't necessarily see that one, but this says the government deficit. And these are all the elements that go to define the government deficit. The work we're doing in the current version of Minsky, and I'll just bring it up and show it on screen, we'll take those elements and put them over here on a variable tab or a parameter tab. So all that complexity that you can see in that model will be disappear, and you'll just have these various tables that include the actual financial flows. This is actually a model, another significant model, a model of the shadow banking sector. And the guy who did this model is now working for the Bank of England as one of their experts on shadow banking. So Minsky can handle large scale stuff. If you wanted to do a model of your national economy for a PhD, you could do it in Minsky. So it's not just toy software. I use it at a toy level compared to what some of my students are doing now. So it's going to get much, much better over time. You've seen some of its potential there, I think. We'll see if any of you have ever seen anything like it before we talk in the question period. We're adding a whole lot of features to it now, courtesy of a grant from an organisation called the Friends Provident Foundation. We're going to have better graphics. We're going to support a multi-sectoral view of the economy. We're going to dramatically reduce the clutter of the program and so on. We're going to give it possible to run it just in a browser. You don't need to install to run it. And we're going to have proper documentation finally, probably in late 2020. And that's the basic story. If you want to support my work or keep in touch with my work, that's my Patreon page up here. Just to support Minsky and keep in touch with Russell Standish's work to build Minsky, that's Russell's page. I'll just bring them both up so I can show them on screen. If I'm lucky, let's see. Yeah. TikTok, TikTok. So there's my Patreon page, and this is Minsky's Patreon page. The a slow connection courtesy of all the other data I'm uploading, I suppose. So that's it. I'll take questions. Over to you, Joram. Fairly fast, I'm afraid, but still.
Yes, very great. Great and disciplined. So, thank you, first of all. I just wrote in the chat, everyone should see on the bottom, maybe, there is a few symbols, and one of them is chat. You can also press out and out plus H. And in the chat, you can just write head to ask a question. I already see that Samuel has a question. Yeah?
Of course.
Yeah, either take your time or write it in there already now. Then I will go through the list and I will unmute you now.
Yeah, great. Thank you very much for this talk. It was really interesting. I mean, I think I read your Debunking Economics book and got to know Minsky in 2011 or 12 or something like this, and didn't get in touch with it for a while, and was really impressed to see like the complexity of the models, or like the real world models you built in the meantime. And yeah, my question is quite obvious, I guess. You already wrote also your newest book about it. So with all those, with the complexity of the model you have now at your hands, can you say something about modeling the current global economy, so to say, or the prospects for future economic crisis? I read summaries about your current book, like what you say about, but it would be really interesting building on your monetary macroeconomic model, like what you can say where we are standing at the moment, what are the prospects for the next 2 or 3 years?
Yeah, on that front, I don't see a great potential for serious crisis on the financial sector, except in countries like Australia and Canada that managed to avoid the crisis back in 2008 by massively increasing the amount of money they were borrowing. So I'll just actually give you an indicator of that. This is another program I make a large amount of use of, which is called MathCAD. I'm adding some of MathCAD's features to Minsky over time. But if I take a look at the level of credit in America, for example, and I'll just actually rapidly bring that up. This is just showing you the same data I showed a moment ago in terms of the level of debt in America, private debt compared to GDP. And what you can see, and that's just, forget about Austria, it's just the default labeling thing there. I'll just actually turn off that label. Actually, I'll make that debt as the label. What you can see by looking at that chart, I'll just make it a bit larger here, is that we're at a very high level of debt compared to GDP historically, higher in fact than the Great Depression, substantially higher than back in the 1870s. But debt was rising for a while and is now falling again. So if I add to this chart, and I'll just rapidly do that by typing in a new, new function here. So I'm going to look at the change every 12 months to private debt in America, and then add in that to my graph here. And this is now going to be credit. I'll just go back and define that to be credit. And then put in a 0 line so you can see where zero credit is. Okay. Again, make it a bit larger. What you can see, credit is it's recovered from being negative, which is was during the depth of the crisis, but it's flatlining at about 7% of GDP versus much, much higher peaks in the previous 50, 60 years. So credit demand is very low. The reason it's very low is debt levels are too high. People are unwilling to take on too much more credit. Banks are unwilling to extend too much more credit. That gives you a low level of credit demand. And to have a crisis like we saw back in 2008, you need to have a high level of credit demand. What this gives you is not a crisis, but stagnation. And that's the situation that I think you find America is in. I can rapidly convert that to show you what Japan is like, because in my way of thinking, Japan is the the canary in the coal mine that could have told us what was going to happen. So that's, if we'd taken notice of it, we hadn't done it. This is looking at Japan, which preceded what happened in America by 25 years. So a higher level of private debt than in America. It reached a peak back in 1995 or thereabouts. It's had negative credit or almost zero credit for about 25 years. And it's only just starting to recover now that its debt level is bound at the same level as America. So I see stagnation rather than another crisis, in so many words.
Thank you, yes.
Great. You can also, of course, type your question if you have maybe problems or you're on your phone. But so far, I don't have someone on the list now, except myself. But
We'll dive in.
I will keep it to myself if anyone else wants to ask something first. Because my question is not directly related to the work you've done in this context, but something else. I'm not too sure. Maybe some people have seen it now when it comes to climate change economics.
Yeah.
And I've read one of your critiques or critique of the Nordhaus model, which was which got the so-called Nobel Prize.
Yeah. What an insult.
The first part of the question is just to make people aware of what you've done there, and maybe could you just outline that a little bit, your critique, because I thought it was very important. I know some people are into climate change economics.
Okay. Well, if you go to my my Patreon blog, by the way, most of my posts on Patreon are freely available. The only posts which are not available to anybody at all are the podcasts, because they're an income source for my podcast guys, so we have to make those just for subscribers. But anybody, you don't have to sign up to read the posts. Okay, I would like you to sign up because it helps me extend my research and so on. But if you don't, you can still read the post. So I'm filling in time and waiting for the thing to download so I can show you that those posts. If you go to the post tab on my Patreon page and click on climate change, that'll limit my posts just to the ones that are on climate change. And again, it'll take a while before this turns up. But I thought when I started looking at climate change that I would find the reason that neoclassicals had got it wrong was because they used equilibrium models and stuff like that. I haven't even got to the stage of pulling apart the Ramsey model they're using, because there's only one word for it: the shit, the garbage they've done as assumptions to build their models are the real problem. I've never seen anything as bad as they've done on climate change. And I'll just go through and show you one of my more recent posts on this. So I'm going through and finding, how did they build the data that they allegedly fitted their models to? And the basic answer is they made the numbers up. There's no better way to describe it. I want to show you on this particular post here. There are 4 methods that economists use to fit what they call their damage functions, to say how much GDP is likely to decline with an increase in temperature. And if you read Nordhaus's Nobel Prize speech, or you read a paper he wrote in the American Economic Review in 2018, he literally says that a 6-degree increase in temperature will cause about an 8% fall in GDP compared to what it would be in the complete absence of climate change. Now, at the same time, people like Mark Linnaeus in a book called 6 Degrees, which I highly recommend people to read, he said at 6 degrees, life will basically cease to exist on the planet. How do you reconcile the two? Simple. Mark Linnaeus is talking about the real world. Nordhaus is living in a fantasy. And I want to indicate the level of fantasy here because they've got about 4 different approaches they've used to get the data to which they fit their functions. And one of them they call enumeration. And they describe that. This is quoting Richard Toll, who's he's supposed to be a professor of environmental economics here in Amsterdam. I don't take his, I find his work horrifyingly bad. But here he says, in the enumeration approach, estimates of the physical effects of climate change are obtained from a natural science paper, and then given a price and added up. And for agriculture, you might take the impact of increase in temperature on climate, on crop yield, and then work out the economic impact of that. That sounds reasonable when you first read it. But I don't trust these people. I've got plenty of reason. Just debunking economics, maybe not trusting a classical economist in the first place. But reading Nordhaus, everything I've read has been garbage. And so he claimed at one point to have used a paper by the Environmental Protection Authority to estimate the impact of climate change on a few sectors. But as this is a paper back in 1991. And notice what he says here. The sensitive sectors are those which are exposed, where the output depends upon climatic variables, temperature and precipitation. At the other extreme, things taken in carefully controlled environments will not be affected by climate change. He then says, well, 3% of the economy is affected by climate, 10% is moderately sensitive, 87% is unaffected. So in supposedly adding up the damage from climate change, he's assumed that 87% of the American economy won't be affected by it. That's just an assumption because it happens indoors, quite literally. It won't be affected because it happens indoors. That's the level of sophistication there. Now, this is a table which he produced in this same paper. I'll make it a bit larger so you can see the text slightly better there. And notice he has, this is the percentage of impact. These are the sectors he said will have negligible impact. Manufacturing and mining, transport and communication, finance, insurance, and the rest of real estate apart from that, which will be affected by rising sea level, trade, government, and he's just ignoring the impact of climate change on those sectors. Now, he then, to give an idea of just how bad this work is, here's a table where he says this is the estimate of the impact for all those sectors on how much they're likely to decline in billions of dollars in 1981 dollars terms. And he says farms, which are going to be like less severely affected, minus 10 billion to plus 9.7 billion. Okay. Electricity demand, minus 1.65 billion. And then these are three things with climate, from increasing sea level, total about 5.5 billion. Now, notice you said here, underlying data are summarized in the EPA 1988. Translations into empirical by the author, details available on request. Well, thank God I found the report on the web, the final version rather than the draft. And here's what they say about electricity. Their estimate is 33 to 73 billion, not 1.65. Okay. Somehow he reduced 33 billion to 1/20th of that in his supposed impact of climate change. Now, I think what he did was, the EPA said, assuming no change in technology or efficiency. So I think he said, let's add fairy dust. Let's assume a really high rate of technological change, and we can reduce it to 1.65 billion. It is garbage work. There's absolutely no justification for that massive reduction in the estimated impact of climate change and electricity demand from 33 to 73 billion by the EPI to 1.65 by Nordhaus. And that, I just found that just continues all the way through their work. Everything I look at is something as bad as that. One more, if I can just indulge for a bit and bring back one more of the reports I've looked at here. Pardon it'll take a while because we're using so much of the data, of my data here to download the graphics. I'm trying to, I might actually bring up one of the reports I've written on that front, which you just bear with me to get to a file so I can show what I'm trying to show there.
Yeah.
Hang on.
Yeah.
So, any other questions while I'm still wobbling around here a bit?
I have just asked the same question in the chat.
Yeah, it's incredibly bad work, and it's bad work about the most serious issue that faces humanity. And of course, if you think about how politicians react, they don't really care what scientists have to say. They worry about what economists have to say. So politicians, these guys write the IPCC reports. So they would be getting some advisor to read the IPCC report sections on climate change, on the economics of climate change, seeing that there's going to be fairly minor effect according to the IPCC report itself, written by economists and then ignoring it. So I'm trying to drag this thing up to, I want to show a document here and, finally, okay, pardon me. Two displays can be a bit of a pain sometimes. Okay, let's hope this will maximize to the right screen. My computer's overloaded right now, as you can see from its behavior here.
Yeah, it seems like it.
Oh my God. Okay. This is a book I'm writing called The Economics of Extinction and the Extinction of Economics, going through Nordhaus's work in quite a bit of detail. And this is what I wanted to show at the moment. The two major ways they've developed data, inverted commas, to fit their functions to is the enumeration approach, which, as I've showed, they assume 87% of industry won't get affected. What they call the statistical approach says we can use current GDP and temperature data to predict what's going to happen with climate change. So we look at temperature in various parts of America, GDP in various parts of America. You get a scatter plot like I've shown here with a very weak relationship, which you can sort of fit with a quadratic, which is what they've used, a quadratic. And they then say, well, if temperature rises by 10 degrees, this curve predicts that there's going to be a fall in GDP of about 19%. Okay. Now that is garbage. That is like saying, we know the slope of a mountain north to south. It's very flat, so it's quite safe to walk along. We don't know east-west. We assume it's the same as north-south. Go for a walk east-west. You walk east-west, you fall off a cliff and kill yourself. It's that level of stupidity about how they've done the data. So I'm more horrified about the work they've done on climate change than anything else I've read in the whole of economics. And that is deadly because, at least with the financial crisis, I knew that central banks could rescue it to some extent and government spending could rescue it, et cetera, et cetera. There's no rescue for climate change. And these guys have trivialized it. And now we're going to walk into the scale of dangers that are far greater than their stupid models and stupid parameters would ever indicate.
All right, we have some who has a hat on now, yeah?
Yeah, me again. Yeah, as you were mentioning your newest book, it really looks and sounds fascinating. Great play of words, indeed. Do you see any potential that with the climate crisis looming, that we will see something like a more rapid shift in economics than we had after the financial crisis? Because from our perspective, it took like a financial crisis 10 years ago for us at the Network for Pluralist Economics to ally under the banner of pluralism, and now 10 more years to launch our e-learning platform. And now we have about like, I don't know, 20,000 visitors per month, but it's like piecemeal change. And we see like we need time to institutionalize alternatives, which however create more niche, but do not transform the whole scientific discourse or system. So like the general question would be, what's your prospect, or do you think we will see at one point more rapid change or like revolution in economics, or what do you think of the future of the economic profession?
Yeah, I'm quite horrified by the situation we find ourselves in, because when if you look at like the wildfires that are occurring in Australia right now, it's literally my hometown, Sydney, surrounded by bushfires, pollution levels which are killing people. This is what happens with rapid climate change, because in that particular case, a drop in rainfall and increase in temperature means more evaporation. Plants can't be sustained anymore. Everything is dry. A spark and bang, you get a bushfire that wipes out. If the area that's been burnt so far is bigger than South Korea, okay, that's the scale of those fires. They're gigantic. Now, all that is completely ignored by these guys. And yet people have been trusting people like Nordhaus, and of course getting a Nobel Prize makes it look like it's even more trustworthy. Of course, it makes it even more suspect, since we know there's no such thing as a Nobel Prize in economics. But when people realize how badly they've been conned, then I think there'll be pitchforks out for economists. I think the days when people say, oh, you know, we couldn't have possibly seen the financial crisis coming, that's the excuse they've all used. It was an exogenous shock. If it becomes obvious just how badly and totally intellectually shallow way they've distorted the dangers of climate change. When that becomes obvious, I think there'll be people out to arrest them for climate crimes, quite frankly. And in that situation, I'm going to be saying, look, this is a dangerous ideology that has led us to potentially, if not an extinction event, then the verge of an extinction event. This is not a good way to analyse capitalism, as this is where it leads you to. Okay? So it's far beyond anything with the financial crisis. And because with the financial crisis, there was a rescue which was feasible afterwards with government spending and cutting interest rates and so on, it hasn't been a terminal crisis. This could well be a terminal crisis for capitalism. I don't believe that capitalism will survive as the primary way we organise production on the planet once we realise how serious this threat is. We're going to need massive war-scale, war economy focus on building renewable energy systems and war economy rationing. And in that system, forget about capitalism, okay? It becomes a war economy. And in a war economy, people are going to say, well, who's guilty of getting us into this war? And Nordhaus and his friends will be ones who'll be lined up for being guilty. It's a pretty drastic way to get rid of a stupid theory, but I think that's what's going to ultimately happen.
Right, then I have Henry on the list.
Yes, hi, I'm Henry from the German Network for Pluralism in Economics. And I have a question about shadow banks in your model.
Yeah.
And what do you think about the shadow banking sector, and how is it integrated in your model, and is it necessary to do it?
Is it necessary to have a shadow banking system, you mean?
Sorry?
Does it mean necessary to have a shadow banking system, or necessary to have shadow banking in a model?
In your model.
Yeah, and that's a model by an ex-master's student of mine, Nick Jackson, who's currently working for the Bank of England now as their expert on shadow banking. I'll bring up that model actually. I just have to go back and give me a second just to go to the right stage in my slides here. And hang on, I'll show the model to you. So Nick built this. Nick actually has a background in engineering, which is why he was able to do this so quickly. Literally, he did this as part of his master's thesis. And then when he applied for a job at the Bank of England, he got hired straight away. And now he's their expert on shadow banking, or one of their experts on shadow banking. Just give me a second to get to the right page to show that. I'll bring it up on screen now. One of the hassles about a model like this is I can't explain it. Okay, I didn't write it, but I'll bring it up here and show it to you. It's a big model. And let's make it, it goes right off the screen there. So these are all the definitions. And again, all this stuff I'll just zoom in a bit to show you that a bit more easily. In the next version of Minsky, all these definitions can be removed from what we call the canvas and whacked over here. So it won't be as hard to read as it is at the moment. But I'll put the whole thing on screen. It's a monster, okay? And all the logic is contained in these various godly tables. I'll dive inside one of them and show it to you. So these are all the flows that Nick is modeling in his system. You can see valuation, margin calls, borrowing for repo, borrowing collateral, issuing bonds, government spending, incredibly complicated stuff. You could never in a million years design the equations this generates yourself. To show you what those equations are, and brace yourselves. That's a small selection of the equations of this model. Now, there's absolutely no way anyone could ever draft these by hand. You've got to have a tool like Minsky to be able to build equations of this complexity and keep track of all the dynamics. So what Nick did with this model was set up switches. You can see these little objects down here. These are actually switches. And he can turn on and off various compositions, whether there's low levels of collateral or high levels of collateral, whether there's low feeling about risk or high feeling about risk. etc., etc. And he played out 18 different scenarios and then said what was the impact of different policies in those 18 scenarios. And that's how he's now helping the Bank of England advising the Bank of England how they should handle the shadow banking system. So it's massively complicated. A lot of the complication, like these things up here, if I just select them, that stuff could all be removed from the screen. Those are just definitions. But the actual flow logic is all the stuff along here. And that's showing the chain of reaction between, you know, some change in the level of margin calls, for example, how that'll feed through to demand for collateral, et cetera, et cetera. So it's massively complicated. It's not the sort of thing anybody can look at and understand straight away. I think it's obvious, okay? But it's a tool that lets you analyze the complex system the way nobody could ever analyze it beforehand. And that's the main strength of a thing like a system dynamics tool like Minsky. Pardon me. We might get Nick to give a talk one day on shadow banking.
Nice. All right. I have no one else on the question list, and we're already at the end of the hour. So first of all, definitely we are learning how to use Zoom, I think. From you, Steve. But yeah, I want to thank you. We want to thank you for providing this for us. And I want to thank everyone that joined today. Yeah, we will maybe even upload it on Exploring Economics, so we'll definitely give you the recording of this session. So just be patient for that.
Okay. Right.
And
just on my front, just go to, if you want to download Minsky and play with it yourself, download the beta versions. The betas are stored on a website called SourceForge, as well as on the Minsky home page. So I'll just go across and show that if you go to, let's see, there's Russell's page, so you can download from Patreon. But also if I go to SourceForge, this is the website sourceforge.net/project/Minsky, and you can then go here and choose files and download the beta builds. And so the most recent one was just version 2.17.6, which was released today. So download that, install it, play with it. There's not a lot of, if you go to YouTube, you'll find I've got a few lectures on how to use Minsky. So if you go to my YouTube channel, I'll bring that up. Let's see. All right, come over here and go to my channel. And you'll find, amongst many other things, there are workshops on using Minsky. Okay, so that'll give you a guide on how to drive the program. Please do take it out and start learning differential equations and system dynamics. That's it from me.
Perfect. All right. Yeah, then I would close the meeting. Just for the ones from the editorial team,
okay, great.
Online for a little bit longer if you have any other questions. Otherwise, we just keep chatting via Slack, I think. And yeah, again, most of all, thanks to you, Steve, for being available, and good luck for the rest of the new book also.
Mm-hmm. Thank you all. Okay, and good luck for you. Keep on giving them a hard time. They deserve it.
Yes, thank you very much.
Thank you. Okay, bye all.
Bye-bye.
I'll look it up now. Okay. Let's see.